I'm going to teach you how to implement a different view of the world, one from the car's perspective. And we won't use any libraries to get this effect, because the math is surprisingly simple, and I thought you may want to know how it works. I actually learned it myself by watching this video. The method I'll teach is a little bit different because our car can also turn around like this. We needed to see things from any angle, but the math is almost the same. I recommend checking that video out if you want to get another perspective. Get it? Perspective? Because we'll implement. No.
Gonna code, debug, and have fun. Coding with Radu. Coding with Radu. Gonna prototype and design. Coding with Radu. Coding with Radu. Let's code now.
Before implementing the 3D view from behind, let's make some changes here so we debug faster. First, I don't want to wait for this 3, 2, 1 counter. Then the noise. I don't want explosions while I talk when debugging. And I don't want the car to get damaged. We'll move around the world and try to see the buildings from different angles. And if we get damaged all the time, it's not going to be fast. So I'm going to mute the site. Now, if I start here, you can see that there is this mute icon. So the noise is not coming anymore. And then in Race.js, we are going to set started to true already in the beginning. So that counter is not going to stop us from going anywhere. And in car.js, where we assess the damage, here I'm just going to return false. So now if you save and refresh, there's this crazy thing going on because the damage doesn't happen for any of the cars. And we can also do that. We can go out of the borders. There is no noise disturbing while I talk. And we didn't have to wait for this 3 to 1 to happen. We'll revert these things at the end, but now for debugging, this will speed up things quite a lot. Let's implement the camera. So we will have a camera object sitting where the car is, and we will try to render what the car is supposed to see in its world. Let's go to Race.js. After we have my car initialized here, and let's define a camera on top of my car. So we give my car to the constructor. Now let's implement this object, and we are going to go to race HTML somewhere here. I'm going to duplicate this sound.js and let's call it camera.js. Save this file and control click will create the file. And now we can begin to write our class. The camera class, the constructor. We have passed there the car, but anything with an x, y, and an angle will do. So it's going to make sense if here I'm going to destructure the object and say x, y, and angle. And the variable names are also shorter, so it's a win-win. Now let's set these attributes. The x is going to be x, y is going to be y, and z is going to be -20, because we think that the camera is going to be a little bit above the ground where the car window is. Now let's set also the angle. This will change when the car is moving. And I want to define here a center point just with the x and y values, because I like this point object. It didn't exist when we implemented the car in phase 1, but now look, we can go here, make the draw method on a given context, and use that center to draw itself. And we don't have to do arcs and things like that. And we have options here, like we can make it red, for example. And let's call this draw method so that we can see where the camera is placed at to debug. in race.js, all the way at the bottom, right here, just before we increment the frame count, I'm going to say camera draw on the car context. Save and refresh, and now you can see this red dot here over the car. Let's go to the camera object and give to the constructor also a range. How far should the camera see? And let's say it's 100 pixels for now. After the angle here, we are going to store also the value for this range. And let's create a point here called tip. And this is going to be a new point based on the x and y and with the range and the angle. So we are going to say this dot x minus this dot range times sine of this angle. Now this looks a little weird because we are using the kind of rotated unit circle from phase 1 relative to the car's coordinate system. But this will work. So let's do the same thing here with the cosine on the y. And now we should get a tip point offset to the center according to the angle and the range. Let's draw this one as well. And we're gonna do that here. I don't specify the color anymore because we can distinguish from them like that. Save and refresh, and you will see here in front of the car we have that tip of the camera. But if we move the car, the camera should follow. So that's the next thing that we are going to do. We are going to go here and implement a move method for our camera. And it's going to need these same x, y, and angle. And this really is going to do pretty much the same thing that we have here in the constructor. So I'm going to copy, but we don't have the range. So let's remove that from here. And to keep things clean, we can leave just the range in the constructor. And after we have it, we can call this move at x, y, and angle. So we initialize the object using the method we just created. But we created this method so that we can call it in race.js here. Above where we draw the camera, we first move it to my car. Let's save and refresh. And now you can see here when moving the car, the camera also follows. Now, the cameras typically have this kind of viewport there. So let's generate now a point on the left and a point on the right at that range and draw that kind of triangle there. So in camera.js, maybe here below, we can copy this tip 2 more times and say left is a new point like that, but we are going to change this angle and say minus 45 degrees or pi divided by 4 in radians. And this is going to be right. And here we are going to add 45 degrees like so. And now that triangle is a polygon, and it's nice that we have the polygon object. We could use here this poly is a new polygon, and it's going to be an array of points. So let's just pass here this center, this left, and this right. And we can use this one now to debug here and say this poly draw on the context. Now save and refresh, and this is the triangle. So you can see now how it's following the car there. Neat. Now we would like to render to see what the camera is seeing. So now it's intersecting that house there. I would like to see the corner of the house and from the car's perspective. We're going to use another canvas for that. And let's go to race HTML at the top here, and I will duplicate this car canvas and write here camera canvas for the ID. And in race.js at the top, let's set these up. I'm going to make the car canvas just half its height and at the top so that the camera canvas can fit in the other half at the bottom. So here divided by 2, and let's copy this below for camera canvas and camera canvas here and here and here. And now we need the context for that one as well. Let's copy this, paste here camera canvas, and camera CTX will be this. Let's save and see if it works. And it doesn't really work. What happens is that the camera canvas is here, it's pushing this one to the left. They need to be vertical. So I'm going to go here at the top and say that the body style flex direction is going to be column. This will align them vertically. Let's save and refresh. And now you see this is the car canvas and the camera canvas is here waiting to be rendered. So we will work with both of these canvases. Here the camera is being drawn on the car context just to see where it is. And below that, let's say camera render the world on the camera context. And the world, we need to say what do we want to render there. Buildings, trees, whatever, road borders. And let's implement this method next inside of the camera.js. Here, above the draw method, we will have render on a context, the world. And we will only focus on polys, no details or anything like that. And the first polys that we will play with are the building bases. So let's take these out from the world buildings by mapping them to their bases. The base is the poly of the bottom of the building. And let's debug. For now, we just draw all of these polys, not on this context from here, not on the parameter, but still on the global variable, this car CTX. We just want to see what these polys are and remember how they look like and see what we expect in the rendering to happen. Now save and refresh, and you will see here those blue polys there appearing at the bottom of each house, even in parts of the map that don't render the house for efficiency, like here. So now when we are looking at a house like this, like what is happening here, we expect to see this corner of the polygon, but from the car's perspective. It's kind of silly that this viewport is so small, so let's go here and make this larger, like 1000. And now this is more like it. At least we can see some full buildings here. These pieces of paper are those building bases. Now, here's what we see from this angle. Quite different, right? They're not rectangles anymore. What we'll need to do is figure out new coordinates for each point. I'll put this screen here for reference, and let's try to figure out the screen coordinates for this point. Let's call it P. Now, imagine a line here coming from the camera. We don't really need to imagine it, we had it already when we calculated that tip earlier. What we'll first do is project P on this line, like so. Let's call this new point P1. See this right triangle here? It intersects the screen, making another similar triangle here. Now, this screen can be anywhere. What changes is just the zoom, pretty much. So let's say it's 1 unit away, so really close. We do this because it makes the math easier. You see, when triangles are similar, this length divided by this length is the same as x divided by 1. 1 goes away, so we have our x. Now, to figure out why, we look at things from the side, like this. On computers, the vertical axis goes down like this, so our camera is at a negative z value. Now let's simplify a bit and focus on this triangle. There's another similar triangle here, but upside down. This is the y that we need. So y divided by 1 is equal to minus z divided by this length, and we have our y value. Now these x and y are on the screen that is 1 pixel away. We won't see much if we leave it like this. My diagram was not to scale previously. So we still need to multiply these using the size of the canvas we want. Let's go to the render method and prepare to transform these polygons from those that we see from the top view to those from the car's perspective. And I'm going to say that those projected polys are going to be formed by remapping the existing polys somehow. So each poly from those at the top is going to become a new polygon where we map each point of this poly into a new one, a projected point. You'll see. And these projected polys are the things that we will indeed draw on this context. So when they will be there, we can clear the canvas here like so. And do another for loop like below, but now from projected polys like that. And when we draw on CTX. So the only thing we need is this method for projecting the point. Let's implement it up here. Project point on a context P. And the first thing we do is get the segment connecting the center of the camera to that tip. So let's get that segment. And now, considering this top view, let's get the projected point on the segment. So I'm going to take just the point from the projection and call it P1. This is going to be projecting the point on the segment. And now the x is going to be the distance from P to P1 divided by the distance from the camera from this to P1. We'll also need to scale this by the canvas size, but for now just imagine that the canvas has a half width of 1. And the y is going to be equal to minus the z value of the camera divided by the distance from this to P1. Again, this is true if half the canvas height is 1, but it's not. We have to scale it considering that as well. And let's have here some helper variables. The cx is going to be half the canvas width, and let's have cy half the canvas height. And we don't want to scale independently. We want to use the same scalar, otherwise we get distortions. And for now, let's just set this scalar to be equal to the minimum of the two. So the last thing we do here is return the new point, where we add to cx x times the scalar, and we add to cy y times the scalar. And let's see what we did. Save and refresh. And something looks very strange there. It's a little better if we move far away. But why is stuff appearing just on the right side of the screen? Well, the offset on x that we are calculating here can never be negative, so it can't go on the left side of the screen at the moment. We need to figure out if the point is supposed to be on the left side of the screen. And we can do that by calculating the cross product. So C is going to be the cross product between the vector starting at the camera and pointing at P1 and the vector starting at the camera and pointing at P. So we just want to see if it's on the right or on the left of P1. And then what we do here is multiply by the sign of this C value. So if this is going to be a negative value, then that's going to flip horizontally. We don't have this function anywhere at the moment. I think we should be adding it in the world.js and then inside of math utils. Scroll down and let's add it below the dot product for vectors. So I don't have any material explaining this function, but I also don't plan to explain it now because it would break the flow too much. I'm sure you can find resources for it, and maybe I'm gonna add something in the description if I remember. But let's see what happens. So save and refresh. And now there are things on both sides, but some strange things are going on. It kind of makes sense if you look at everything from here. Like it seems like the world is coming close to us. But then when we are getting too close, strange stuff starts to happen. And the problem are points that are behind the car here. I mean, going back to our formula, this distance here from this to P1, it gets smaller and smaller as we approach some object, but then when we pass the object, it gets larger and larger. So basically it makes the object come back in front again, which is not what we want. But the natural way to solve this is to really just keep the things inside the viewport. Like we don't care about these objects here. We only need to worry about the things inside of this triangle. Now, let's go here in the render function, and instead of just using all the building bases here, we are going to filter them. So we are going to say this dot filter. It's going to be a private method that we have to implement. And let's implement it here just above render. Filter polys. This will return some filtered polys, so let's just prepare here the result variable. And let's loop through all of the polys like this. And if this poly, so this means that triangle that we see in front of the camera, contains poly, then we add it to the filter, to the filtered polys like that. And let's return the filtered polys here. Now this contains poly doesn't exist at the moment. We have to add it here to the polygon primitive. There are many methods here. There are some for contains point and contains segment, but there is nothing about contains poly. So let's have it here. And I don't want to check if it contains the poly entirely, just one point is enough. So, because we do want to see the thing, even if it's a little bit there. So I'm going to filter here those points that are inside of the triangle region, and then count how many they are, get their length. And if this length is greater than 0, then this return is going to be true. Otherwise, this is going to be false. Let's save and refresh. And now you see that not all of these houses here are blue, only if they are touching and inside of this triangle region. And if you look down here, it's better, but still not perfect somehow. There are still some problems happening. Like, for example, now. And this is because this poly here is still having points that are going behind the car, causing that problem. We really need to keep just points that are inside of this triangle. We're going to do that by breaking these polygons and keeping just the part that is inside of the triangle. So in this case, there is this triangle, and here we have this pentagon. Let's close this polygon.js. And back in camera.js, we are going to change the logic here a little bit, and we will say if the camera triangle doesn't contain the poly, then we go here and say continue. We don't care about that if it doesn't even cross a little bit. And now, if the polys intersect, we will have to make that logic for breaking the polygon. But if not, else, then we do what we had previously. So let's go here and break the polys, but I don't want to transform the original polygons. If we do that, then they're going to start getting a lot of points and mini segments everywhere as the camera moves. I don't want that. It will complicate them for no reason. So I'm going to get a copy of the polygon we are intersecting, and also a copy of this poly, like so, and break now the two copies. And now with the broken polys, we are going to take each point of the poly we are looking at and then filter them so that they are inside of the camera triangle. So filtered points is going to be points, filter those points that this poly contains. And now the polygon formed from these filtered points is what we add to filtered polys. Push a new polygon with these filtered points. Let's save and refresh. And you can see some kind of fidgeting happening there. And the reason for that are the points that are exactly on the intersection here may appear to be inside or outside. There are small differences in the decimals there. So we need to also force those points on the intersection to appear all the time. And we can do that in a number of ways, but I think the most elegant one is to just say here that if the point is on the intersection or if the poly contains the point, then we keep them, but we don't know if the point is on the intersection or not. So I'm going to modify this polygon break here and pass it a third parameter. This will say if we want to mark the intersections or not. And we have to modify again the polygon here. Look inside the break method and add this third parameter here, mark intersections. By default, we don't need to do that, so we set it to false. And here, when we have this intersection point coming from the segment intersection, after we have it as a point object, we can tell it if mark intersections is on, then point intersection is true. And now this should work. Save and refresh. And you can see now the polys up here look look really nice. When we are inside of the poly, we see this part of the triangle here is missing, but that won't really bother us because in the real game we can't do that. So I'm not going to worry about this issue. But look, now I'm trying to go between these two houses, and this looks really good. Like I'm actually going between those two houses in the car's viewpoint. Yeah, nice. We can make this view larger though, changing here inside of the camera JS project point method. Instead of using minimum here, we can use the maximum. And there we have it, a much larger viewport there.